Today we'll discuss about JEE Men's 2016 paper Physics. All students, let us move to the next question. Question number 11. A uniform string of length 20 meter is suspended from a rigid support. A string is suspended from a rigid support of length 20 meter. This length is 20 meter. A short wave pulse. A pulse is generated at the is introduced at this lowest end here, and the pulse is to travel up. It starts moving up the string. The time taken to reach the support is, so this wave has to reach this point. The final situation will be something like this. Here it has to reach here. So how much time it will take to reach this point? This is the question. Given that you take g equals to 10 meter per second square, this is s to the power minus 2, this is s minus 2, ms minus 2 meter per second square. Anyway, so out of this to find which one is the correct answer. Now basically what you do is that as we move up, in a string, the velocity of wave in a string is given by velocity of transverse wave is given by t divided by mu root. This is the formula for velocity of transverse wave in a string, and this mu is for mass per unit length, linear density of the string, and this is the tension in the string. Now the thing is that if I move up, so when it is here or when it is here, the pulse will reach somewhere here, then tension will be different at different positions. Okay, so this is variable. So if this is variable, then I have to use integration to solve this question. So let us say at a distance x, or I consider this distance y direction, then at a distance y, I consider a point P, and from the lowest end, and C, I'll consider a small section of this string, that is dy width, and this portion of the string, and I want to find and this wave is moving, this pulse is moving in this direction from here to here. From here to here, it is taking time dt. Then dy over dt will be my speed of the pulse, speed of the wave from this point to this point. That means when it crosses that small dy length from here to here, dy length, it takes time dt. So this distance is very very small, infinitesimal small, so that I can assume that the speed there remains the same, because otherwise the speed will not remain the same, because it depends upon the tension. The string is uniform. String is uniform means that the mu value is constant. This is constant, but this t is not constant, because the T is tension that equals to the if I consider this point of the string, then the weight of the string lying below will create a tension. If I consider this point, then the tension in the string will be 0 at this point, because there is no length of the string lying below this. If I consider a point here, then the total length of the string will whatever its mass, that will contribute to the tension. So from this I choose this as the origin. From here, from this origin 0, I move up y and consider an element dy, and in this element, what is the tension in the string? The tension is due to this length of the string, the weight of the string lying below this point, which is the length equal to y. So the mass of the string hanging below mass of string hanging below this dy element is y into mass of string hanging below dy element is y into mu. Why mu? Because mu stands for mass per unit length, and to this length of the string, so this gives you the mass. So tension T becomes mass into G, so it is mu y into G. This is the tension. So if I use this portion, then I'll use these are the tensions, and the velocity will become, let us say, what is the velocity here? So this velocity is v. So or v at a distance y. So v equals to tension, that is mu y into z divided by mu under root. This is the velocity at that length, dy length, from here to here when the pulse is traveling from here to here during this displacement dy and time taken as dt. I'll consider that the velocity with which it is moving is this velocity, because the path is so small that I don't find appreciable change in the tension in the string as the pulse travels from this point to this point. So therefore I will write and then I can cut this one, and the velocity at this point to this point is only y into g root. Now then I have to find how much time it takes. I suppose that this is time taken, and this has to, with this velocity it has to move this distance. Thus this speed is definitely equals to this distance it has to travel, and this is the time taken for this. If I do that, then I will write dy, rearrange this, dy over y root equals to, then g is multiplied here, so under root g and gt. I rearrange this equation, dy and this root y will come down, this root g will remain there, dt is multiplied, and then taking the integration on both sides of the equation. Why integration is done? Because we want to find how much time it will take for this length of 20 meter, starting from length equals to 0, the pulse has to travel up, and time taken is, suppose the time taken is t, so I have to integrate 0 to t. Here the limit will be 0 to t, and here the length will be 0 to 20. Okay, length is 0 to 20. This has to cover this distance. So by integration, how to integrate that? This is y raised to minus half. If y raised to minus half, then it will become y raised to minus half plus 1 divided by minus half plus 1, and that goes from 0 to 20. Okay, then this is under root g is a constant quantity, and t here t varies from 0 to t. Okay, I will solve this to get the answer. This becomes 1 minus half, so y root of y divided by, this is half, 2 root y. So this is 2 root of y, and this varies from 0 to 20, and that varies from under root g of t varies from 0 to t. So I solve this to get the answer. If I put substitute here, this is 2 root of 20 minus 0 equals to, this is root of 10, because this is given the question as 10 meter per second square, and this becomes t minus 0. So I solve that, then it is 2 root of 20 divided by root of 10 equals to t. So then time taken by the pulse to reach the highest point, the fixed point of the support is 2. Then this I can write as 2, 20 is 2 into 10, so it is under root 2 and under root 10, divide by under root 10, so that will give me this will cancel out. This will give me 2 root 2 seconds. So from here I conclude that the time the pulse will take to reach the highest point is 2 root 2. So this pulse will take time 2 root 2 to reach this point. So this 2 root 2 is the correct answer. So option number 3 is correct option. Okay, so what I've done is I have to take the help of integration to solve this question, because the tension is variable as the pulse moves up, so velocity also varies. So there is variable velocity and variable tension. So you take the help of integration to solve this. Okay, thank you.